We're on lesson 2.6. This is part 4. I'm just doing these in little sections for y'all. The degree of the numerator is 1 greater than the degree of the denominator. We have an oblique asymptote. So if we have f of x equals x squared minus 3 over 2x minus 4, and we want to find the oblique asymptote, we're going to have to divide. 2x minus 4 divided into x squared minus 3. Now what is it that you would multiply 2x by to get x squared? Well, you'd have to multiply it by x, and then you'd also have to multiply it by 1/2 to get rid of the 2. So it's going to be x over 2. So this is just plain old long division. X over 2 times negative 4 is negative 2x. And x over 2 times 2x is x squared. Change your signs. So this is, those won't combine, so I end up with 2x minus 3. 2x goes in there one time. Get negative 4, 2x, change your signs, remainder of 1. So this tells me that f of x is equal to x over 2 plus 1 plus, here's your remainder, 1 over 2x minus 4. This is your remainder part. This is your linear part, g of x. As x approaches positive and negative infinity, the remainder, whose magnitude gives the vertical distance between the graphs f and g, goes to 0. If x is going to infinity, this is going to be really large. This is going to go to 0. Okay? So the slanted line, or the asymptote, is going to be x over 2 plus 1. That would be the equation of your line, which is your asymptote. Okay, sometimes when we take the limit, we get infinity as an answer. So I'm going to look at example 10. If I ask you to find the limit as x approaches 1 from the right of 1 over x minus 1. Okay, the limit as x approaches 1 from the right. So it's coming in from the right, so it's going to be numbers like 1.1, 1.2, 1.3. And let's make a quick little table. Let's do 1.5, 1.4, 1.3, 1.2, 1.1. So when I subtract 1 from that, that's x, and this is 1 over x minus 1. So I'm going to have 1 over 1 divided by 1.5 minus 1, which is 2. 1 divided by 1.4 minus 1, which is 2.5. 1 divided by 1.3 minus 1, which is 3.3. What's happening to our numbers? 1 divided by 1.2 minus 1, which is 5. And 1 divided by 0.1, which is 10. So what's happening to those numbers? Those numbers are getting larger. And these are just very, very, very few of these. But as this happens, this limit is going to approach positive infinity. It's going to infinity. Now, let's look at what happens to the limit as x approaches 1 from the left. As x approaches 1 from the left, the numbers in my table would be numbers like 0.9, 0.8, 0.7, 0.6, 0.5. I think I built that table backwards. That's not what I want to do. As I approach from the left, I want to build it where it's 0.5, 0.6, 0.7, 0.8, 0.9. 1 over x minus 1. So, plug that in. 1 divided by 0.5 minus 1 is negative 2. 1 divided by 0.6 minus 1 is negative 2.5. 1 divided by 0.7 minus 1 is negative 3.3. Repeating, 1 divided by 0.8 minus 1 is negative 5. And 1 divided by 0.9 minus 1 is going to be negative 10. So we see that we're getting the same thing, but they're negative. So the limit as x approaches 1 from the left of 1 over x minus 1 is negative infinity. So let's discuss the behavior. Let's look at 11. And let's discuss the behavior of f of x equals 1 over x squared as x approaches 0. As x approaches 0 from either side, the values of this are positive because we're squaring x. So if my difference is negative, I'm going to square. It's going to turn into a positive. So that means that the limit as x approaches 0 of 1 over x squared is equal to infinity. This number is going to be very, very small, but it's going to be positive, so my answer is going to be infinity. Now, example 12. Example 12. These examples illustrate rational functions can behave in various ways near 0 and near the zeros of the denominator. Limit as x approaches 2 of x minus 2 squared over x squared minus 4. So what we'll need to do is we'll need to factor this, and this is going to factor into x minus 2 times x minus 2 over x minus 2 times x plus 2. Of course, we'll simplify here, and we'll have this is really, I should put limit here. Limit as x approaches 2. Limit as x approaches 2 of x minus 2 over x plus 2. What's going to happen to the numerator as x gets really close to 2, it's going to get really, really small. As x gets really close to 2, this is going to get closer and closer to 4. So it's going to approach 0. It's going to get, the numbers are going to get smaller, 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 so they're going to approach 0. Part B says evaluate the limit as x approaches 2 of x minus 2 over x squared minus 4. So this is the limit as x approaches 2 of x minus 2 over x minus 2 times x plus 2. Let's cancel. This is the limit as x approaches 2 of 1 over x plus 2. Now, the numerator is going to be 1. The closer and closer and closer x gets to 2 has nothing to do with the numerator. It's 1. The denominator gets really close to 4, so this has a limit of 1/4. Part C, the limit as x approaches 2 from the right of x minus 3 over x squared minus 4. Well, I'm going to factor that. I'm going to be studying the limit as x approaches 2 from the right of x minus 3 over x minus 2 times x plus 2. Okay, as x gets closer and closer to 2 from the right, so it's going to be numbers like 2.1. Okay, what's going to happen when it's 2.1? That's going to be 0.1. That's going to be 4.1. These numbers are going to get very, very (2.1 minus 2 times 4.1, and then what's the numerator going to be? 2.1 minus 3. It's going to be a negative. So you're going to have a negative here. You're going to have a very small number here, so it's going to approach negative infinity. Okay, example D. We want to find the limit as x approaches 2 from the left of x minus 3 over x squared minus 4. Well, this is the limit as x approaches 2 from the left of x minus 3 over x minus 2 times x plus 2. Now, as x approaches 2 from the left, it's going to be numbers smaller than 2. So that's going to cause the top to be negative, but it's also going to cause the bottom to be negative, because if this is less than 2 and I'm subtracting, I'm going to get another one that's negative. So a negative over negative is a positive. This one's going to go to infinity. E, the limit as x approaches 2 of x minus 3 over x squared minus 4 is equal to the limit as x approaches 2 of x minus 3 over x minus 2 times x plus 2. Well, go back to the previous two we looked at. These do not have the same answer, so the limit as it approaches 2 does not exist. Part F, limit as x approaches 2 of 2 minus x over x minus 2 cubed. Okay, I'm going to rewrite this as the limit as x approaches 2 of negative 1 times x minus 2 over x minus 2 cubed. Now I can take this and one of those. So of negative 1, I have the limit as x approaches 2 of negative 1 times nothing, it's all gone, over x minus 2 squared. So as x approaches 2, this number is going to get very, very small. This is negative 1. It's going to turn into negative infinity. I'm going to stop there with this video. Next one we'll pick up with the example 13.